So let's do another example involving the dot product. So we've seen the dot product. The way to calculate the dot product of two vectors in R3 is to do this calculation. And the reason that people care about the dot product is because of property 2. If it weren't for property 2, no one would be taking dot products. Property 2 says when you do this dot product, it gives you information about the angle between two vectors. So I'd like to start with an example. I've drawn two vectors here on the page, the vector 4, 2 and the vector 1, 3. And I'm going to drop a perpendicular onto the vector 4, 2 from the vector 1, 3. So I've got a 90-degree angle here. My question is this. I'm going to draw a vector that looks just like this red vector. Let's call that vector W. So the question is, what is the vector W? Okay, I'm going to answer this using dot products. So why don't we call this vector 1, 3? Why don't we call that vector U? And why don't we call this vector V? There's an angle between the two vectors, U and V. Let's call that angle theta. Well, now I know that U dot V satisfies condition 2 here. The vector W, how am I going to find it? Well, I know the direction. Vectors have two pieces of information encoded, a direction and a distance, a length. So I know the correct direction. The only thing I don't know is how long this vector W should be. So the idea is I'm going to first I'll find the length of W, then I'll actually find W. Well, the dot product of these two vectors is given by equation 2. So the length of W, using right triangle trigonometry, should equal the length of U times cosine of this angle. Well, if I divide both sides by the length of V, right, that's almost the same expression. So that's actually U dot V divided by the length of V. So now I have the length of W. The actual answer is W is in the direction of V. Here's how to get a vector in the direction of length V of the length you want. You first find a unit vector. So a unit vector in the direction of V is 1 over the length of V times V. This is a unit vector in the direction of V. Then I'm going to take my unit vector and scale it to have the length I want. The length I want is here. So this is a constant. I'm going to multiply my vector by that constant to make sure my vector has the appropriate length. So I'm going to write this as U dot V, and I'm going to divide by the length of V squared times V. This is my answer, but let me actually put the numbers in to see what this is component-wise. So U dot V, if I take the dot product of these two vectors, I get 4 plus 6. So U dot V is 10. The length of V squared would be 4 squared plus 2 squared, and that's times the vector V, 4, 2. So what do I get? 10 over 20? Is that 1/2? So this would be 1/2 the vector 4, 2, which gives me the vector 2, 1. Okay. I'd like to finish this video with an important definition. So here's a definition, a term that you need to know. So two vectors, u and v, are orthogonal if their dot product, u dot v, is equaling 0. What does orthogonal mean? That means their dot product is 0, meaning the angle between the two vectors has to be a 90-degree or pi over 2 angle. Cosine is equal to 0 at the radian angle pi over 2, or 90 degrees. So this means that u and v are at 90-degree angles of one another. Let's finish with an example of two orthogonal vectors. So if I do 1, 0, -1, dotted with 0, 2, 0, then these two vectors are at 90-degree angles of one another. I take their dot product and I get 0 plus 0 plus 0, the number 0. Let's try to plot these two vectors in R3 just to get an idea of what's going on. So here's my three-dimensional axis system. There's x, there's y, there's z. So the vector 1, 0, -1 says I'd travel 1 unit in the x direction, 0 units in the y direction, and 1 unit down. So the vector 1, 0, -1 is the red vector as shown. And then the vector 0, 2, 0, that's a vector that's a distance of 2 in the direction of the y-axis with no z and no x component. Well, it may be difficult to see, but these two vectors are indeed at a 90-degree angle from one another. That means these two vectors are orthogonal. Okay, great.